Hi, in this video, we're going to discuss about metallization. Metallization is to connect the metals uh, between devices. By connecting devices, we can make the integrated circuit. Nowadays, there many devices are connected to multi-levels. This can make the devices even more complex. Traditionally, we made contact point with etching and deposit the aluminum to connect the devices. However, nowadays, we deposit the oxide and open the connecting holes and insert the via metals. Uh, Usually, we nowadays we use tungstens to connect the devices. Uh, Even though we used to use aluminum to connect the devices, but aluminum has some bad points, such as aluminum spiking and electromigration, because aluminum is relatively soft and light metal. With with electric forces, aluminum can move to unwanted area. Moreover, aluminum tends to uh, move inside the silicon, so it can make the it can make the devices to work poor. Moreover, by shrinking down the sizes by without making the contact without making contact to move current better, we always have contact resistance. Without shrinking down contact resistance, the devices cannot be work better as cannot work great as desired. Uh, with connecting aluminum and silicon directly because of the energy barriers, we have the Schottky energy barriers, so it will have ohmic beta Schottky resistance between beta and silicon, but by but by inserting a shallow oxide between metal and silicon, we can by with the tunneling current, we can make the we can make the Schottky barrier to work like ohmic contact like. This is because by putting more dopant into silicon, we can make the depletion region even shallower, and by putting extremely narrow oxide between metal and silicon, we can make the current flow through by tunneling current. Uh, Previously, we used to use aluminum as for metal, but between of the because of the down bad things uh, we have told before. Currently, we use copper, gold, and so on, and plug in tungsten directly into the directly to the devices. Silicide. Let's move on to the silicide. Silicide is a compound that is made with metal and silicon. By putting silicide in between the metal and silicon, we can make the contact better because silicide is compounded with silicon and metal. So, uh, uh, so by putting silicide between the polysilicon and metal, we can block the metal even better. And with nitride, there is there is bar- there is there was like barrier. Uh, this prevents from the metal from seeping into another devices. Connecting the devices to another devices is done by electroplating. This uh, electroplating is not as is not as comprehensive as the deposition, but but doing electroplating is much cheaper to than deposition. There is another way to make the better contact, that is self-aligned contact. With the self-aligned process, we can make the device to devices to work even though the over even though with the overlay problem. However, the overall performance will be worse. Between the metal and between one metal and another metal, we put dielectric to cut the current. However, we also need to cut the electric field. So, unlike the high K metal gate, high K elements we in high K metal gate process, we put low K dielectric between metal and metal. Thank you for listening.